This video is on position versus time graphs. The letter we use for position is usually X, but it could also be Y or Z. VS stands for versus, T stands for time, of course. And when you write it this way, position versus time, with position before the word versus, that means when you make the graph, position goes on the vertical axis. Whatever word or thing comes before the word versus goes on this vertical axis, and what comes after the word versus goes on the horizontal axis. So that's what position versus time means. It tells you where to put the quantities, which axis gets which. The single most important thing to know about any motion graph is to think back to what's really going on, to reality. And these all start from the idea, in 9th grade at least, they all start from the idea that you have like a road and the miles are marked on it. So like you might have 0 there at a border, like between Pennsylvania and Ohio, for example, on the left-hand border, or where California meets the ocean, that's 0. And then you have marks that are spaced 1 mile apart, like this, 1, 2, 3, 4, 5, like that. And these are miles on a highway, and that's how we tell where a car's position is. So, for example, if the car is sitting right here, we say its position, we use the letter X for that, is 3 miles. It's at the 3-mile marker. And if you're on a highway and you pay attention to the exit signs, you'll see the exits have numbers. That tells you which mile marker you're at on the highway. So that's what you always come back to, is the idea that when we say position, we're telling where a car is. A car is able to move left or right on a straight road, and every mile on that road is marked. Of course, it doesn't have to be miles. It could be feet or yards in a football game, inches on a ruler. It could be anything as long as you have a straight road and distance intervals are marked on that road with numbers. Okay, that's the single most important thing to keep in your mind when you're doing motion graphs, is the idea of a car being able to move back and forth on a straight line that indicates position. What makes this kind of difficult is, we think of cars going left to right, but when we make the graph, we take this thing and we turn it this way. So this is 0 down here, like California meeting the ocean, and this is traveling to the right, and this is traveling to the left. And so these bigger numbers mean up to the right, these smaller numbers mean over here to the left. That's just the way someone decided a long time ago to make these graphs, to put position this way and time that way. Okay? But it became confusing because in real life you can think of the car going sideways, left and right. Okay, let's make a graph. Here I've got a position time graph made. This axis is position in miles, and that tells, another word for position is location. It tells where the car is. Okay, so that's on here. And in this axis is time in hours. And an easy way to start getting a handle on this is to think of this 0 here, where time is 0, that's noon. 1 means 1 o'clock in the afternoon, 2 means 2 o'clock in the afternoon, and so we're keeping track of a car as it moves on an afternoon, and the time starts at noon. 0 is noon. Then we have this is our number line, like the car can move back and forth on it. 0 is like where California meets the ocean, and then we have 10, 20, 30, 40, 50, 60, 70 miles. So these are miles. Okay. Let's think of a car. Hey, what we do is over here I write the motion in words that we want to describe, and on the graph we'll show what kind of graph that makes. So car A is going to be in red. It's going to be the simplest possible motion, sitting still, not moving at all. So we have a car that sits still at the 20-mile marker, so that's here, for 4 hours. Okay, that means at noon. So you have to coordinate, you have to make coordinates by matching the time from down here with the position from up here. So it says when we start, we're at the 20-mile marker, so put a dot there. It stays there for 4 hours, which means at 1 o'clock, it's still, when the time is 1, the position is still 20. So see how that works? 1 o'clock in the afternoon, 20 there, and we take these two things, 20 going that way, 1 going up, and it makes a dot. 2 in the afternoon, it's still there. 20. So put a dot. 3 in the afternoon, it's still there. So that's 1, 2, 3 hours. And finally 4 in the afternoon, it's still there. Okay, so that makes some dots. But it didn't just disappear between 1 o'clock and 2 o'clock. It was at that same location, the 20-mile mark, all that time. So that's what the graph would look like. If something is sitting still on a position graph, the line will be horizontal. The graph will be horizontal, and it'll go through all the times that the words describe, the first 4 hours. And then we'd have no more information, so the graph stops there. Okay, now let's look at car B. This is still at the 70-mile marker for 4 hours. So we'll go a little faster now for that first part. Car B is blue, starts at the 70-mile marker at noon, and it sits there for 4 hours until 4 in the afternoon. So it sits still, so that position isn't changing. I look at 2:30, I go up, oh, it's there. That means the position is 70. Okay, staying at that position 70 the whole time. Then this car starts to move left at 10 miles per hour, and I didn't write it, but it should also say constant speed. A constant speed of 10 miles per hour to the left. Okay, so let's think of what that looks like. 10 miles per hour to the left, so 1 hour after 4 o'clock. So at 5 o'clock, it's moved 10 miles per hour for 1 hour, so it's moved 10 miles to the left. To the left from 70 is to go to 60, not 80. Think back to our number line, right? And make this easier to think, I'll just add zeros to it. Okay, 70, I guess I have to do it this way. 70, 60, 50, 80 miles. Okay, this car starts at the 70-mile marker, and 1 hour later it's gone 10 miles left, so it's here. So this is noon, this is 1 p.m. Keeps going at a constant 10 miles per hour, so in 1 hour later it's 10 miles more left, so that's 2 p.m. Okay, that's a picture, that's not a graph. Now let's look at how we do that on the graph. It sits still for 4 hours. Then 1 hour after that, so when it's 5 o'clock in the afternoon, it's gone 10 miles left because it says 10 miles per hour left. An hour more, 6 o'clock in the afternoon, it's gone 10 more miles left. 7 o'clock in the evening, 10 more miles left. So see, the position has gone from 70 to 60 to 50 to 40. That's moving left. Okay, and at 8 o'clock at night, it's at 30. And of course, the graph has to be, we have to join these points. The car exists in all those times in between the hours. So that's what it looks like. So this kind of negative slope means moving left. And every time we went over an hour, it dropped down 10 miles to indicate moving left. So that created a straight line, not a curved line, a straight line. And the straight line is what you get when there's constant speed. So negative slope means moving left. Straight line means constant speed. Okay, next example. All this is still exactly the same as before. Car A in this case will be in red, and it starts at the 10-mile mark, so we'll put a dot there. Starting at the 10-mile mark, it says it sits for 2 hours. So 1, 2, so it's sitting an hour later, it's sitting in the same place. So at 1 in the afternoon, still at 10 miles. See how you read up and over? 2 in the afternoon, go up and over, still at 10 miles. So it sat still, so that made this horizontal line for 2 hours. Then it moves right at a constant speed, again, of 10 miles per hour. So now I think, how do I move right? Right means the position numbers get bigger. So 1 hour later, I have to be at 20. So I go over 20. 1 hour later is 3, so there's to be a dot there. Okay. Then an hour after that, it has to be at 30. An hour after that, 40. Because each hour, it's going to the right 10 miles, and that mile marker is getting 10 miles bigger each hour. Okay, and that creates this. Similar to before, but now this is a positive slope, and that means moving to the right. Okay, let's see what's going to be different about car B in blue. It says that everything's the same. The only thing that's different is the speed. So it's going to sit still for a while. Then it's going to have a speed moving to the right at 20 miles per hour. So now 1 hour later, instead of going 10 miles, it's gone 20. So it's like that. 1 hour after that, it's got 20 more miles. So instead of being at 30, it'll be at 50. And so forth. Okay, this also has a positive slope, so that means it's moving to the right. The numbers, as the clock ticks and the time goes into the later afternoon, the position values up and over, up and over, up and over get bigger, which means moving to the right. And this slope is steeper because each hour the position changes by more than it did for the red one. So steeper slope means faster motion. The blue one's going faster, so it gets a steeper slope because every hour the position changes by 20. The red one has a shallower slope. It means moving slower because every hour the position only changes by 10. That's 10 miles per hour for the red, 20 miles per hour for the blue. Okay, next graph. Each of these graphs, by the way, is teaching a lesson, moving left, moving right, moving slow, moving fast, standing still. So this one has a new lesson. Okay, car A is going to be in red. Start at the 20-mile mark. So that's right here. Okay. And start 20 miles, already going 10 miles per hour. Speed right, and it's a constant speed. So it's already moving. So that means 1 hour later, moving to the right. So 20 to 30 is to the right, then 30 to 40. So noon it's at 20-mile mark. 1 it's at the 30-mile mark. 2 o'clock in the afternoon it's at the 40-mile mark. 3 o'clock in the afternoon it's at the 50-mile mark, and so forth. So you get that. Okay, the slope is positive. Positive slope means moving to the right. Okay. The line is straight, so that means constant speed. Okay, now let's look at car B in blue. Also starts at the 20-mile mark. It says it's not moving. So you get this, not moving as we've seen before. It doesn't say how long it's not moving, so that means you get to decide. I'll make it stand still, not moving for 1 hour. Okay? Then it starts to move right, but with increasing speed. So let's say in the first hour, it only goes 10 miles. I'm sorry, 5 miles. In the first hour, maybe it only goes 5 miles to the right. The next hour, from 2 to 3, maybe it goes 15 miles to the right. So from 25 to 40. And maybe in the next hour, from 3 to 4, it goes 30 miles to the right. So from 40 to 70. So I go 4 p.m. in the afternoon, 70-mile marker. So look at the shape you get. Okay? The red one's straight, which indicates constant speed. This one's curved. The blue one is curved, which indicates changing speed. Okay, slow, or stopped, then slow. See that shallow slope? In fact, right there, it has the same tilt or slope as the red one. So at that time right there, they're both going the same speed. But then the blue one starts to have a steeper slope, which means faster. Each hour, it's gaining, it's going a farther distance, so it's going faster up here. So this is slow, and this is fast. Okay, and our last one. This is a story, and you're supposed to put the entire story on one graph. Okay, so we go through one part at a time. Everything that's written down here you have to put on the graph, and you're not allowed to put anything on the graph that isn't in here. You can't make up anything of your own. Okay, so first says it starts at the 50-mile mark, so that's there. At t equals 0 or noon, it starts there. Then it says it's parked. So we show that it's parked by doing this. That should be very familiar by now. Staying at 50-mile mark for 1 hour, parked. Okay, check. Next, very quickly increases the speed to a constant speed moving left. So that means it's going to go 50 to 40 to 30. And when it says it very quickly increases speed, that means you can make this happen like an instant corner. So it starts going like this, so I'm going to make it 2 hour mark, it's at position 40, and at the 3 hour mark, it's position 30. Okay, so there's that moving left with the negative slope, constant speed, straight line, Each hour, it moves left 10 miles. 1 hour, moves left 10 miles. 1 more hour, moves left 10 miles. Up and over, up and over. Okay, so we did B. C, it says gradually slows to stop. So that means we have to change from being like this to being like that, stopped. So there should be a curve. Gradually slows to a stop means that there's a curve like that instead of a corner. So there it stops. Okay? All right, so there's parked. A very quick change to moving left at constant speed, and then a gradual slowing to a stop. Okay? There's where it stopped, where it's starting to flatten out. Okay? That's C. And then it says it immediately reverses direction. So instead of moving this way, left, it's going to start moving that way, right, and goes right with increasing speed. Okay, well, we've seen that before in the previous graph. Each little unit of time that goes by, it should go further and further that way, so you get this curve, it gets closer and closer to pointing straight up. Okay, so this is part A, this is part B, this is part C, and the rest is part D. Okay, we'll sum up some general hints. Hints and shortcuts. Okay, for position time graphs. The other type of graph, velocity time graphs, are completely different. Nothing in this video helps with velocity time, just position time. Okay? This means staying still. These all mean moving right. They all have positive slope. As time increases this way, they all get higher and higher in the, remember this is the x direction, the position direction. They all go to bigger numbers, which means numbers to the right. Okay? So what would this mean? These mean? These all mean moving left. They all have negative slope. Positive slope means if you imagine walking left to right, you're always climbing. No matter whether it's straight or curved or how it curves, you're always climbing. That indicates moving right. Positive slope. For these, if you're going left to right, you're always descending, going downhill. That's negative slope. That always indicates moving left, because as the time ticks off this way, you go up and over, up and over, up and over, the position numbers keep getting smaller. Okay? The closer the line is to being flat, the closer the car is to just sitting still. So an almost flat line means slow. A very steep line means fast. That can work the other way too. This is steep, it's fast. This is almost flat, so that means slow. Okay? Curve means changing speed. And so look at what kind of results you can have for curves. There are 4 basic types of curves. This has a positive slope. As you move left to right, it climbs. So this is moving to the right. It starts out very steep, so it starts out fast. It ends up flat, like something stationary, so it ends slow. Remember, steep is fast, horizontal is almost stopped, and is slow. Okay, now let's see if you can do this one. That's almost horizontal, so this is slow. This is very steep, that means fast. And as you go left to right, as the clock ticks, the numbers on position get bigger. Up and over, up and over, up and over. The numbers get bigger, so this also means moving to the right. Now look at this one. This is very steep, so that means fast. This is almost level, so that means slow. We can go over this one. This must be slow because it's almost level. That's all very steep, so that means fast. Okay. As you go left to right, up and over, the position numbers are getting smaller, so this means moving to the left, and so does this one for the same reason. So those are shortcuts you can use to make and interpret graphs very quickly.